Hello everyone. Today in the Let's Practice video we are going to discuss a practice problem based on a organic name reaction. The practice problem is that when cyclohexanone is treated with sodium hydroxide followed by heating, what will be the product? I think here we are familiar that carbonyl compounds can undergo two different type of reactions in presence of sodium hydroxide or potassium hydroxide based on the presence of alpha hydrogens. Now this is a carbonyl group and now these two are alpha carbon. So alpha carbons have alpha hydrogens. Now when a carbonyl compounds have alpha hydrogens, then in presence of sodium hydroxide or potassium hydroxide, it undergoes aldol condensation reaction. And when a carbonyl compound doesn't have alpha hydrogens, in presence of NOH or KOH, it undergoes Cannizzaro reaction. Now here you can see cyclohexanone, it has alpha carbons and alpha hydrogens. So that's why it will undergo aldol condensation reaction and will be getting the aldol condensation product. Now let's explain the mechanism of aldol condensation reaction and let's see which compound, which product we are getting due to aldol condensation reaction. Now here this is a cyclohexanone and these are alpha hydrogens. So in presence of base OH minus will abstract this proton and here one carbanion will form. Now this carbanion can undergo ketoenol tautomerism. Adjacent carbonyl compounds, carbonyl functional group is present. So here this electron movement will be like this and negative charge will now move on the oxygen. So this is called ketoenol tautomerism. Now here sometimes we are quite confused that which carb C minus or O minus, which one is going to act as a nucleophile. Like due to ketoenol tautomerism, negative charge is moving from the C minus to O minus. So now which site will be a good nucleophilic site? So one thing we have to understand that oxygen is more electronegative than carbon. So since oxygen is more electronegative than carbon, oxygen wants to hold the electrons rather than donating it. So that's why the C minus will be acting as a nucleophilic site. Now in the reaction mixer we have another cyclohexanone molecule. Now carbonyl carbon is electrophilic in nature. So now nucleophile will attack to the electrophilic carbon. So it's a nucleophilic addition reaction. Now we'll be getting this intermediate. This negative charge carbon is attacking to the electrophilic carbon and we are getting this intermediate. Now this O minus will be attacked by H plus and it will be converted to OH. So if it is alpha beta, so then it is alpha beta hydroxy ketone. Now since we are heating the reaction mixture, so here water molecule will be leaving and now see the movement of the electrons. So OH will be leaving as a OH minus. Now adjacent proton, it will donate its electron bonding electrons here. It will be leaving as a H plus. So finally the molecule will be leaving as a water molecule and here we will be getting a double bond. So now this is a alpha beta unsaturated ketone. So alpha beta unsaturated ketone is the final product of the aldol condensation reaction. I hope the reaction mechanism is clear and you understand the which product we are getting from this particular reaction. So thank you for watching this video. If you have any question related to chemistry or related to aldol condensation reaction, you can send me a mail to chemistry.affinity@gmail.com. Thank you.